So let's say instead of individual measurements like we've been taking here, what if we use a morphometric parameter like roughness to describe the surface treatment and make comparisons between them? So first, it's useful to ensure that your meshes are segmented, because something like this edge of the potsherd is going to throw off the roughness calculations, because as I've noted in the exercise, these calculations depend on something called nearest neighbors, which in statistics, that means outliers will throw off the calculations. Nearest neighbors is a statistical method that looks at points around a point to see if it is considered abnormal or not, which will make a bit more sense as we get into actually looking at roughness. So here I will ensure that my mesh is a bit more segmented. Right. So when you're segmenting your mesh, you'll want to make sure it's relatively flat, because anything that is substantially different from the norm will throw off calculation a bit. So want to get rid of the edge of the sherds, keep a little bit of this undulation because we don't want to ignore the surface itself either. And so that's roughly flat. Okay. And for this exercise, I'm going to import pH 19 and pH 20 as well, though you're welcome to import any others that you found interesting. So now you'll want to align all of your meshes so that they are flat on their own respective planes. Right, now again, this is one of those functions that uses the vertices as the source of information. So highlight your vertices layer for each mesh and then click Tools, Other, Compute Geometric Features. And so for this one, we're going to select roughness. There are other options which you can play around with later. And then we're going to set this at a consistent kernel radius throughout. So for each of these, we're going to use the same number. So I used 3.16383. And then we're going to let that calculate. Great. So you can see the surface here, and so areas with less roughness will be the dark blue and more roughness will be red. And the way you can see the actual scale next to it is by scrolling down here and clicking visible, and so you can see there's a histogram that pops up just here. Okay, and then you repeat these steps for all the rest. So after you've calculated the roughness for each of these, it should look something like this, though it will depend on which segments of the pot you've taken, because these are all based on nearest neighbors, so the neighbors will be different depending on where you've selected, which part of the mesh you've selected. So the neighbors will be different depending on which part of the 3D model you've selected. So you may notice that the visualization of roughness actually is quite useful in a visual sense as well, in terms of determining manufacturing processes. So If the automatic visualization settings don't really bring these out, what's useful is looking here down in the properties of a potsherd. So let's say 12 here, because we aren't seeing too much detail here yet. And so if you go to the SF display parameters and click on the red triangle, it'll slowly bring these out. So you can see these striations that are typical of wheel-thrown pottery here. So as we're kind of comparing the roughness fields for each of these potsherds, again, these will be different than the numbers in the handout, just because it depends on which part of the pot you've sampled. But as you compare these roughness values, you might notice that some are characterized a bit differently than what you'd expect. So in the case here, pH 12, our maximum is 0.60, which you wouldn't really expect. You wouldn't expect this to be very high in comparison to pH 21, which has lots of clear undulations of the surface because of how it's decorated. So you might want to take a look at the histogram next to it. So if it's different from what you would expect based on what you can see in the 3D model, it might be caused by some of those outliers I was talking about. So these are things that, I mean, it could be post-depositional processes, like if you notice these deep pits in TC23, the deep pitting is something that happened after it was put into the ground, probably, and so it doesn't really tell us anything about manufacture. For this one, I think the main issue here is that we've got too much of the rim, or just before the rim, so you can see where the areas that are considered quite rough are highlighted in red, but you can see the rest of it is much less so. So a good way to kind of eliminate some of these outliers that we can see in the histogram on the side. So if we want to negate these outliers caused by post-depositional processes and errors due to sampling edges, then you can look at the histogram on the side, and you also have this option to look at a histogram, a larger one. So if we look at the larger histogram, you get to see the calculations of roughness in a finer grain look at it. And so the larger version is a bit more helpful here. But another way to deal with outliers, so if we take TC23 as an example, have all your settings start at normal, so you can clearly see what is outliers and what's not. Then you drag this white circle on the right side further and further and further. You can see, if you watch this deep pit here, you can see that the center that used to be red is now turning gray, much like the histogram on the right. And so what this is doing is we are decreasing the maximum scalar values to remove these outliers. Now it'll depend on what you think is a good place to stop. So I think there is, because it's starting to get into the actual surface there. So this is still kind of a visual way of diminishing these. And then, so do that for each of your sherds. Okay, so now a more reliable comparison can be made here. You can also adjust your saturation values again, if that's helpful, to see what is going on. You can start, there's the striations there. There's striations there. You can see the brush strokes a bit better there. And that's already pretty well visualized, but we'll go with that. And so you can see the surface treatments a bit more clearly here. So now to try it yourself, take a look at the the larger versions of the histograms here, when comparing these roughness values with the histograms, does this now match up with what you'd suspect based on the surface treatments that you saw? So in this case, based on the shards I chose, 21, pH 21 has more roughness than the rest, so it's at 0.132, which is to be expected because we know that all these undulations and things are in here, despite the fact that it is a very smooth pot. pH 19 and 19 and 12 are quite similar now in terms of levels of roughness. So we've got about 0.1 here and about 0.1 here as well. So that would be to be expected because they both have the striations still quite visible if you've altered it a bit. So it seems like they have not quite as smooth as 21 kind of surface treatment, but there hasn't been anything else added to it. But maybe we wouldn't have expected that TC23 would have quite a similar roughness compared to the other to pH 12 and pH 21 because it has such a different surface treatment. But it must mean that the brush strokes aren't actually as prominent as they appear in this visualization, because otherwise we would end up with a different roughness calculation. So in terms of relative depth, the brush strokes must be around the same as the striations from being thrown on the potter's wheel. So you might have chosen different potsherds here and see if the calculations of roughness match what you were expecting or not. And think about why that might be. And then for your assignment for this one, for your reflect and write section, check out some of the other morphometric parameters that you can calculate under the same drop-down menu. So things like curvature, density, features, surface variation, things like that. Try some of those out. And try those at different settings. And are there any that distinguish between surface treatments better than this? If so, take a screenshot of the parameter that works best and write a short caption underneath the image about why this is.